Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
My name can start.
Your name is Nick. Hello, your name is Nick.
Hello, your name is Marty.
And good evening, everybody. Welcome to the Event Horizon here on Astronomy.FM radio. That means it is another Friday night. This one happens to be October 20th, 2017, 9 o'clock in the evening for those of us here in the eastern portion of North America, also known as Universal Time of 1 o'clock in the morning, October the 21st, Saturday morning, 2017. Hello, Nick.
Now, actually, I'm going to stop the presses because recently, about yesterday, I think it was yes, it was yesterday, in the Eastern Daylight Time Zone, there was a very, very great event. We had a daytime fireball seen. It was seen in Pennsylvania, New York State, and Connecticut, heading out to sea. So, basically, it was a very bright meteor. It was thought to be about magnitude -4, roughly the same as Venus as seen in the morning or evening sky. And obviously it's the Orionid meteor shower right now, so probably connected. And there's been about 30 fireball sightings filed to the American Meteor Society. So this was actually quite a brilliant event. Not perhaps as deadly or as loud as Chablinsk, which I'm probably very grateful for, but never mind. It was seen over Norwalk, Trumbull, Stratford, Milford, West Haven, Danbury, New Milford, Southbury, Woodbury, Torrington, and Middletown. Now, one of my radio amateur friends was talking to me this morning about it, and he said that he'd seen it. He was coming out of Pennsylvania, heading back north into New York State, and he saw a daylight fireball. So this has to be the event, because this is the only one that is reported. So it's quite a rare occurrence for us. And also, it was caught on video. There is footage of this. And let me see if I can copy the video URL and put it into chat. Okay, that shouldn't work. I'm just going to check it in my browser. Yes, it does work.
Good.
So, this is the fireball view from Seagrid, New Jersey. So this is quite a great event, really, when you think about it. We don't get many daylight fireballs here in the US.
Yep.
So, as I say, enjoy the report, because I certainly did. I was a little bit skeptical, but 130 reports about the event seen above New York State on October the 18th at 3 p.m. So again, it was primarily seen from New York and New Jersey, also seen from Connecticut, Delaware, Rhode Island, Pennsylvania, Massachusetts, Maryland, and New Hampshire, heading out to sea. So unfortunately, Steve and Jeff will not be able to recover it, unless, of course, they have a diving bell and a gym suit.
Or a yellow submarine.
Or a yellow submarine.
There you go.
Yeah. It's funny because you say yellow submarine. What have I been listening to in the run-up to the show? It's A Hard Day's Night, Help, and with a little help from my friends. So yes, I have been listening to the Beatles during the run-up to the show. Thank you, Glenn. I always appreciate you sharing good music videos like that. They don't make them like that anymore. It's good. It's enjoyable. You can just sit there. You don't have to worry about flashing lights or anything. And you can just enjoy and listen to this music. Sometimes I think all the animation and whatever detracts from it. But I don't know. It was nice. A nice little preamble into the show. Thank you again. Thank you again, Clink.
There you go. Oh, right. What was I going to say? Oh, yeah. What time was that fireball? What time of the day was it seen?
3 p.m.
3 p.m. in what, Eastern U.S.?
Eastern Daylight Time, yes.
Eastern Daylight Time. I should be able to pull up my star chart here and see if it could come from Orion. When's Orion rising? Not for a little bit here. Let me pull up the date and time here and click through.
If you actually pull up the link, it will actually link you to a map from AMS showing the direction of the fireball. So it was heading out to sea.
All right, well, what I'm trying to find out is if Orion is even up at 3 o'clock in the afternoon. And so it'll be like 15. Let's see. No, Orion's not even up by then.
Oh, so it was one of the stray events that happens. It doesn't matter. It's still fun. It's still enjoyable. And if you got to see it, it's up there somewhere.
Yeah.
Or down there somewhere now, because it's probably dropped into the mid-Atlantic.
That's true,
not to be recovered forever, I guess.
Or eventually, but not lately.
Not likely, not in our lifetimes. So sorry, Steve and Jeff, you're out of luck there, dudes.
Oh, let's see what we got going on tonight. Well, let's see. Let's go through some moon and planets, I guess. Got Uranus at opposition. New moon was just yesterday. Let's see. What do we got? Also coming up here, Saturn. Go ahead.
Okay, in that case, do you want me to do my weekly sky at a glance?
Yeah, you could do the sky at a glance.
Okay, so I'll put the link in chat first.
Do you know that Jupiter's in conjunction with the sun?
Yeah, I know, because I can't see it at night anymore.
That's right.
Okay, Friday, October 20th. The modest Orionid meteor shower continues in the early morning hours for the next couple of nights.
Have you seen any?
I haven't seen any. I was up at 6:05 this morning reading the rain gauge. I could see Orion. I could see the top half of Canis Major.
Nice.
And Sirius was very prominent. And so, yes, it was a very nice, clear sky. I enjoyed it. This is the nice thing about having a co-cross rain gauge is that come rain or shine, you got to be out there reading it. Now, I do my readings at around 6 o'clock in the morning because by 7 o'clock I'm heading out to work. I also like to go onto Twitter, post the results because it goes to my local weather station. Hi, Steve at W10. No, seriously, he has an awful lot of people doing weather watching, and he taps the Twitter feeds, Facebook, and everything to get extra information. So, anyway, back to the astronomy, dear boy, Clink. So, the apparent radiant point of the shower is near Orion's club, low in the east after midnight, and high in the south by beginning of dawn. The morning sky is free of moonlight at the moment, and you can see a possible Orionid meteor max out Sunday morning. Look for Capella sparkling low in the southeast after dinner time this week, and then find the little Pleiades cluster to its right by about 3/5 at arm's length. They raise higher as evening grows late, harbingers of the cold months to come. Upper right of Capella and upper left of the Pleiades, the stars of Perseus stand astride the Milky Way. To the upper right of Perseus, the Milky Way runs through Cassiopeia. On Sunday after dark, spot the W of Cassiopeia high in the northeast. It's standing almost on end. The third segment of the W, counting down from the top, points almost straight down. Extend that segment twice as far down as its own length, and you're at the double cluster in Perseus. This pair of stars swarms in dimly apparent to the unaided eye in a dark sky. Use averted vision. One thing you're going to find out is once your eyes get dark adapted, looking at the side of your eyes is sometimes easier to see faint objects than it is looking directly at them. I think it's to do with the way the rods and cones of the human eye is set up. So, it's visible from almost anywhere with binoculars. It's a lovely sight on telescope. I'm being offered coal and candy. Thank you very much, Starstorm. I shall enjoy that in a moment. It's a lovely sight in telescopes too. Sunday. This is the time of year when when Ursa Major lies down horizontal low in the northwest after dark. How low? The further south you are, the lower. Seen from 40 degrees, New York and Denver, even its bottom stars twinkle nearly 10 degrees high. But in Miami, 26 degrees north, the entire Ursa Major skims just along out of sight, just below the northern horizon. On Monday, look low in the southwest in late twilight for Saturn glowing at about 7 degrees left of the waxing crescent moon, as seen from North America, as shown on the chart. So, Tuesday, now at dusk, Saturn appears almost 6 degrees to the lower right of the thickening moon. Wednesday, the ghost of summer suns. Halloween is approaching, so that means Arcturus, the star sparkling low in the west-northwest in twilight, is taking on its role as the ghost of summer suns. Around October 25th of every year, Arcturus occupies a special place above your local landscape. It closely marks the spot where the sun stood at the same time by the clock during hot June and July, in broad daylight, of course. So as Halloween approaches every year, you can see Arcturus as the chilly ghost of the departed summer sun. Excuse me. Thursday, take a line from Altair, the brightest in the southwest after dark, to the right to brighter Vega, very high in the west. Continue the line half as far onward, and you'll hit the lozenge, or the pointy-nosed snout of Draco the dragon. Its brightest star is orange Evetts, the tip of the dragon's nose, which points towards Vega. And of course, that brings us back to Friday, October 27th. It's a first quarter moon, exactly first quarter at 6:22 p.m. Eastern Daylight Time. At nightfall, you'll find Altair shining above 30 degrees, 3/5 at arm's length to the moon's upper right. Much closer to the moon's upper right, by about 6 degrees, is third magnitude Alpha and Beta Capricorni. Alpha is the upper one. Can you resolve Alpha into a tiny twin pair with your unaided eyes? Binoculars make it easy, and should also resolve Beta alongside another wide double, though its components are somewhat closer and very unequal. And back to Saturday, Altair's a little further from the moon's upper right after dark. Just upper right of Altair by a finger width at arm's length is orange Terra-Z. That must be watching Andromeda again. It looks like Altair's sidekick, but it's actually a much bigger and brighter star far in the background. Altair is 17 light years away. Terra-Z is about 360 light years and 100 times as luminous. I just want to thank the guys at Sky and Telescope, Alan McRobert in particular, for his wonderful star journey around the week.
And around the universe.
Yep.
Oh, let's see. What's up? Don't forget, we got some planets still up there. Of course, Saturn, been mentioning that all along. Pluto, is technically still above the horizon. So just northeast of Sagittarius. And then we've got Neptune, just northeast of Fomalhaut. And the planet Uranus also, which I just said was at, what's it at? It's at opposition. So that's up all night. Still some planets, if you make the effort to look for them. Let's see, what have we got next? How about a little bit of Sirius? I forgot to look where Ceres actually is at right now.
Well, if you look at the belt of Orion and take a line across, it is a very, very bright star. And I actually used Sirius.
Sirius, yes, Sirius. I was thinking Ceres actually.
Ceres?
Dawn mission.
The dog star.
No. Dawn.
Oh, Dawn mission. Okay.
Dawn mission at Ceres. Yes, let me put it in our chat room here. It's just been extended.
Cool.
So they're going to keep on going into 2018, and not too sure how much longer it'll last. Maybe to the end of 2018, approximately. They're going to dip it down into lower orbit. Its lowest point was about 240 miles. Now it's going to be going down to about 120 miles above the surface of Ceres. And while its fuel still lasts, getting some better images and checking a few things like obviously more surface detail, and sampling some of the gases coming off the surface too.
That could be interesting actually, because Although it's supposed to be a minor planet, the fact that it is giving off gases could give some very interesting insights into the early solar system.
Mm-hmm. Especially since it's approaching perihelion.
Yeah, and let me guess, it's going to grow a tail this time and become a comet. No, seriously, folks, this is an interesting thing that a lot of us minor planet specialists have been discovering, is that what they used to think as an inert ball of rock, so it got classified as an asteroid. Then they start coming into the solar system. They start getting closer to the sun for some reason, and then they start growing tails. So what was considered originally to be an asteroid becomes a comet, and what was previously thought to be a comet is occasionally being reclassified as an asteroid. So, as I say, it's probably a nightmare for the guys at the Minor Planet Center. What do we call it? Comet? Planet? What?
Complan.
That stuff is gross, Marty.
Complan?
Yeah. But no, but seriously, it is causing a lot of interesting controversy. And it may actually cause an awful lot of thoughts and ideas about the inner solar system and during the early days to be changed. The fact that we have a space probe high above Ceres at the moment, and that can actually dip down closer and maybe taste these gases and see what is actually being given off, might give us a much better idea. Some of these asteroids may actually turn out to be gravitationally bound rubble. One of Mars's moons certainly is going that way, and it's going to be interesting to see what happens when it finally does get too close. And of course, a lot of the thinking is that both Phobos and Deimos were a gift from Jupiter to Mars, because they were traveling a little bit too close to Jupiter. They got their orbits perturbed, and Mars ended up capturing them. So it's definitely changed an awful lot of thinking. And of course, with OSIRIS-REx on its way to Bennu, it really does open up a whole new horizon. It would be really, really nice to actually bring a sample of Bennu home, to have it in a laboratory so it can be analyzed. Obviously, given the weight limitations, it's not going to be a very big sample, but it will certainly be enough to give us a much better idea, certainly of what Bennu's makeup is, and maybe what conditions were like in the early solar system.
Now, the Dawn spacecraft is actually not going to crash into Ceres. They don't want to contaminate it, so they can't fly it away. So they decided they're going to permanently leave it in orbit. So with no major atmosphere, from the minor planet or from the dwarf planet to drag it down, it should pretty much just remain there until they, send another spacecraft and knock it off or something like that. But yeah, it's just basically going to stay in orbit around Ceres for this one.
I think it's probably going to stay there forever until maybe an Orion-based crew come out to either refuel it or fix it or
grab it and send it into another orbit.
Yeah.
Yep.
So we'll see what happens, but I think the thing is we are getting to a point in our history as a spacefaring race. And, okay, low Earth orbit, not really space. Going to the moon, yeah, that's going to space. Going back to the moon, going to Mars, the asteroid belt, going to the Lagrange points, that is going back to space in a big way. And I think we have a lot of fun things to come. There's a company in Germany, if you grab the link from earlier in the chat room from the latest Sky at Night show, who is building a lunar rover of its own. And they had a really clever idea. They're going to rent instrument space on it. Now, they know how much it costs to have X amount of weight launched so it can be pushed on its way to the moon. they've obviously spoken to SpaceX and everybody else. So they decided that they were going to offer the chance to put your own instruments on it, on their rover. Where are they going? They're actually going to go back to the same area as Apollo 17. So the main object of the rover mission is to see and get idea of what the condition is of the lunar rover that was left by Apollo 17, 50 years ago?
Something like that, yep.
So the idea, of course, is this will give them the information they need to build equipment that can be dropped off, used, left, come back to, reused, and they'll know exactly what to expect. We don't know what the condition is of the lunar rovers. We don't know what the condition is of the ascent stages, from the LEMs. This will be, in its own way,
the descent
stage. Yeah. Thank you. I always get the two mixed up.
Up, down,
down, left, right, left. But seriously, the thing is, by analysing the state and condition of the lunar rovers as in situ, will tell us an awful lot about how we have to build for the moon. It would also be very, very useful for equipment going to Mars. Yes, admittedly, Mars has a much more of an atmosphere than the moon and has regular dust storms. So we will be able to use that information to advantage to allow us to send equipment ahead, to leave it, to come home, send out the next mission, and they will have an idea of what state the equipment is going to be in when they get there.
I got a feeling they'd have a pretty good idea if they came up to the the moon rover, and found it up on blocks.
Wouldn't that be a sight? Somebody's nicked the wheels.
And the battery's gone, too.
Yeah. But, like I say, I can see the value of the science this German company wants to do. Yeah. And by renting out instrument space, they get to launch, they get to do what they need to do, and the thing is, they get to make it pay. Instead of the fact that the US used 4% of the GDP to fund the Apollo program, and now NASA gets 0.5%. These guys are trying to find a way to make space pay. I'm pretty sure Musk and Bezos are making money, but it's kind of the smaller companies who don't have the name and financial acumen behind them get out there too and make a bobble too.
There's a place for me that's made space pay.
What's that?
There's a sign on the building that says space for rent.
Well, they're offering to rent you a space literally on their lunar rover.
There you go.
So your instruments can do science. It's a great way to get out there.
Can you imagine the lunar rover looking like a NASCAR with stickers all over it?
Don't think you can go that far, because from what I can see from watching the sky at night, this guy's rover is pretty much head to tail solar cells. So no NASCAR generation.
There's still got to be a way of putting corporate stickers all over it.
Maybe on the instrument bays, but that's about it.
Always right in front of the camera view. See the camera, the little sign. Yeah?
Yeah, you see the camera with the little sign, and there's the little green arm or little grey arm saying, "We love you, Earth. Go away." Mm-hmm. Roswell Grays, gotta love him. What was that line from Star when O'Neill first meets the Asgards? Because they're Roswell Grays. Marvin, you never know. These androids could get paranoid. These robots could get paranoid. However, I know this is one thing that close to Starstorm's heart, the fact that if we can build our technology better and proof it better, maybe it means Spirit and Oppie can be revived, be refurbished, upgraded, and go on.
Those two, but all of them.
And then go like the Energizer Bunny. It goes on and on and on and on.
There you go. Let's go with almost half hour. Let's go with Maven.
Yeah.
There's a story about Maven in orbit around Mars. Let me put that in our chat room. Discovered a rather unusual magnetic tail on Mars.
It is unusual because it
is.
was supposed to be pretty much dead.
It is. Well, Mars itself doesn't have a magnetic field. Energized particles from the sun are basically energized, magnetized. Mars doesn't have its own magnetic field, but there are parts of Mars around the surface that are magnetized. So it could be like iron ore type of stuff like that. So anyway, there is some interaction between the solar wind and the magnetized material on the planet Mars, enough to actually twist the magnetic field going around the planet Mars. And it's rather unique for the solar system. So, the Earth's got a pretty good magnetic tail, and there's twists and things like that. And Venus does not have a magnetic field, so the particles just go flying by it. Well, Mars is kind of a little bit in between of something that's kind of magnetic and kind of not magnetic. So it does interact with the solar wind in something called magnetic reconnection. So there are lots of twists and turns in the magnetic field. And this was discovered by MAVEN, the Mars Atmosphere and Volatile Evolution mission spacecraft. So it's got a magnetometer on it.
Yeah.
Basically a really sensitive compass, and as it goes around the planet Mars, it notices the direction of the magnetic field and the strength and intensity of the magnetic field, and charts it. They're able to put together it's got a lot of twists in it because of the magnetic material.
That's not really unexpected, because if you think about it, with the sun, we see that literally with the sun on a regular basis.
Yep.
So obviously, the solar particles, the plasma, etc., is reacting with Mars in a similar way, connecting, disconnecting, twisting.
Right. But just not reacting with like a magnetic core of Mars. It's reacting with magnetic material near the surface of Mars.
Well, if you've got a lot of iron oxide loose on the surface in the form of dust, I can imagine it would be very reactive.
Yep. So it's kind of sporadic spots on Mars that's interacting with.
Now, cool. The interesting thing is, one of the other things about the moon that was discussed was, so they brought up the idea of a radio telescope. Where do you put your radio telescope, given all the radio interference on Earth? And of course, a lot of these people now are actually talking about, let's go to the far side of the moon, plonk our radio telescopes there. We can put optical scopes there. We could technically build mirrors from liquid mercury, and we would have perhaps one of the best observatories in the universe.
Wouldn't the sun interfere?
Every 2 weeks. But the thing is, once you're away, the biggest issue they have with radio astronomy is the fact that a lot of the interference is in certain millimetric bands, which we use for our smartphones, that we use for VHF communications on the Earth. They're looking at specific frequencies, and a lot of the gigahertz stuff is actually blocked by the atmosphere. So near infrared is blocked. So the water, I think it's the water vapor emission line that tends to get blocked by our atmosphere. Put it all on the moon, you can build huge steerable radio dishes. You can build much bigger mirrors. Talk about aperture fever. Can you imagine being a professional astronomer on the far side of the moon with a telescope that's maybe as big as Iceland, or bigger, in one single mirror, or group, or using the hexagonal mirror cells to make the one mirror. That would be the absolute in aperture fever, wouldn't it?
It would be. How much, if you want to call it land, does it take to block the signals from Earth? I mean, could you put the radio telescope in like some craters at the North Pole and South Pole of the Moon?
You could do that,
and then you could basically point it all over that hemisphere constantly.
But the thing is, one of the things they noticed with the Apollo missions, they actually timed the duration of radio blackout. And even the SHF and UHF communications from the command modules was gone for hours on end. It took, basically, as long as they were on the far side, they could not communicate directly with Earth. There could be a catastrophe at the landing site, and the command module would know nothing about it until it came around from the far side. And we wouldn't know if there had been an accident with the command module on the far side of the Moon.
Mm-hmm.
So the idea of
I'm just wondering, is a crater rim enough shielding from radio emissions from the Earth?
No, it would have to be slightly on. It would have to be right on the edge of the horizon.
Okay. So if you got a radio telescope in a crater, so that the rim blocks you from the Earth, basically, you should be able to, and you won't get sunlight there either. If you're at the North Pole or South Pole crater, you could pretty much operate 24/7, or 2 week 14. How would you call it on the Moon?
Yeah, it would definitely be like a fortnightly schedule.
2 week 30, I guess it would be.
Yeah. So, but the thing is, that gives you 2 whole weeks solid observations until the sun.
Right.
So by that time, the astronomers there are going to be wanting a little bit more creature comforts than maybe a remote outpost will give them. So whilst the far side is sunlit, we would be able to. In fact, we could probably even continue radio observations. It's not like it's an optical issue. Right.
Don't have to worry about daylight.
No, so you can actually continue 24/7, 365 days a year, your radio observations without the worry too much of radio interference from Earth. Yes, they'd have to put a satellite with it set at a certain frequency to allow communications between Moon. But let's use Elron's name, Moonbase Alpha, and Earth and the teams away. Or you have a radio tower right at the right point so that they can actually use a directional antenna to look at it. A Yagi antenna would be perfect, or a dish. And then you just keep it away from frequencies that you're using for observations. But at the end of the day, it's really a case of what's more important, having pristine radio conditions and a lifeline, or what? But
I'm still thinking polar craters would be better. You can basically up on the rim, you could put your transmitter receiver pointing at the Earth all the time.
I was thinking of using Tchaikovsky as the crater for the actual dish. Right. Have you seen how big that crater is on the far side?
Well, there's a lot of big craters there. Yeah,
absolutely perfect.
I wonder what the biggest full bowl crater is on the Moon.
Well, technically, I suppose that could be one of the Mare.
Well, they wouldn't be full bowl though; they would be filled. Something that would be reasonably bowl shaped, maybe almost parabolic.
Let's see what we can find out, shall we?
Or at least spherical. You go look for that, and I will do a little station identification because you are listening to the Event Horizon here on Astronomy.FM radio. It is another Friday evening. This one happens to be October the 20th, 2017, at 9:34 in the evening for those of us here in the eastern portion of North America. And don't forget, we also have our chat room open, so come on over and visit us in the chat room. You can get there by typing in Astronomy.fm/chat or go to the homepage. You'll see where it says radio chat. Either way, we'll get you to the login. Type in a name, hit login. You'll be in our chat room. If you have any questions for us, feel free to ask them, and we will answer your questions for you.
And
right
I have
there.
your answer.
All right.
Manticurigan crater is one of the largest impact craters on the moon.
Okay. What's the diameter and the depth?
Right, I'm just going to go for that now, because now I've got a name.
All right, I'm going to say hi to everybody in chat. So far, we've got Starstorm, Aquafew, Glenn, Twist Edge, and Optronics. Welcome, and glad to have you all in our chat room tonight. Don't forget, we're going to repeat this program every 4 hours for the next 24 hours. And, of course, we have 3 extra hours of programming to listen into. So keep listening in. All right, what you got so far?
Well, apart from the fact that I completely fooled Google. Okay, from what I can find is the Aitken Basin. It's 1,600 miles across and as deep as 3.7 miles in places.
1,000 miles on the moon goes probably you've got the curve of the planet would wipe out any depth to that crater, though. So I imagine just by the curve of the moon, if you're staying in the middle of it, you might not even be able to see the rim. It's probably over the horizon.
In fact, Aitken Basin is a South Pole crater.
Okay.
It's the equivalent distance from London to Athens.
But I wonder if it has any, if it's really bowl-shaped.
Well, it's got a peak in the middle, unfortunately.
Uh-huh.
But you could actually use that to be a support for the actual center of the dish.
Yes, but you see what I'm saying about being bowl-shaped? If it's on a curved surface, that it might not be bowl-shaped?
But Aitken was thought to have formed about 4.3 billion years ago. And that's just a few 100 million years after the formation of the moon itself, they reckon.
Yes, indeed.
But the whole of whole of this impact crater isn't visible. For the largest crater that we can all see of, we need to go to Mars. And that's Hellas Platina.
Okay. How big's that one?
Okay, let's see here. It's a giant depression with a floor over 4.5 miles below the Martian surface. You could fit every Western European country inside it. And what else? They reckon it was formed about 3.8 to 4.1 billion years ago. It was during the late heavy bombardment period.
All right.
But,
and did you say the diameter?
It doesn't find. Let me just let's just look up Hellas Platina.
Again, I'm thinking that Mars is not that big, 4,000 miles in diameter. So if you've got even a 1,000-mile crater there, it's the spherical shape of the planet is not going to allow the bowl-shapedness of a crater over a certain size.
It's a plain located within the huge. Hellas Platina is a plain located within the huge, roughly circular impact basin. Hellas, located in the southern hemisphere of the planet Mars. It is the third or fourth largest impact crater and largest visible impact crater known in the solar system.
But mostly filled in, I'm thinking.
Diameter is 1,400 miles.
Mm-hmm. So
and
still won't work as a radio telescope or optical telescope.
But certainly not as optical. But maybe it could be used for a dish. And you can always excavate the crater itself.
Mm-hmm. I'll have to do some more research on what's the largest practical bowl-shaped crater on the moon and Mars that you could actually do something like a radio dish with. Got to get rid of that sphere, that globeness to it.
Mm-hmm. Well, every time I go back to the largest lunar crater, it goes back to Aitken Basin.
Okay. So the little different definition of crater that I'm looking for then.
Yeah, so the largest crater is about... let me just pull up this... Oh, Ganymede's got one as well. Got a nice large one as well.
What's that Death Star? Death Star moon?
Mimas.
Yeah. Now that one would probably work a little bit better.
Now, Mercury has Caloris and Rembrandt. Crater diameter is at 963 miles. Rembrandt is 444. Venus has Meade, which is 170 miles. The Earth has 1, 2, 3. I think they missed one off in Canada, but that's Foote at 160 to 190. The Sudbury Basin, 160 miles. Chicxulub at 113 miles. The Moon. Now, it's listing 3 here. Prolasarium at 2,000 miles. South Pole Aitken Basin at 1,600 miles. And Imbrium at 711 miles. So for ratio, Prolasarium is at 86%, Aitken 70%, and Imbrium at 33%. Now, Mars has 3 entries. North Polar Basin, which is 6,550 by 5,250 miles. So that's a whopping 125 to 155%. Utopia, 2,100 miles. Hellas at 1,400 miles. Vesta has 2. Rhea Siva, 310. Venusea, 250 miles. Ceres comes into the act. Caerwan at 180 miles. Yarlode at 170 miles. Ganymede, Epigeius at 213. Callisto has 2. Valhalla and Himdal. Valhalla's 224 miles. Himdal is at 130. Mimas has the Herschel crater at 86 miles, and there is a body diameter here for Herschel, and that's 396 kilometers. Tethys, Odysseus at 227. Dione has Evander at 220 miles. Rhea has 2 entries. Mamaldi at 300. Tirawa at 220. Titan has 1, Minerva, at 244 miles. Epietus has, 4 entries. Turgis at 360 miles. Ellinger, 313. Grenin, 277. Falcheron at 263 miles. Titania has the crater Gertrude, 203 miles. Pluto, you wanted me to mention Pluto? I'm mentioning Pluto. Sputnik Basin is around 1,300 to 9 times 900 kilometers. Unnamed crater at 280 miles. Charon has Mordor at 295 and an unnamed crater at 93 miles. I'll put the link in. It's a fun link. And of course it means I got to mention quite a few places in the solar system. So we really did do some astronomy today. Can't beat it. And of course, you know what the greatest thing about having a radio telescope on the moon is? I could moon hop, drive my moon buggy to just the right point of the libration. I could point my 2-meter Yagi at Earth and go, this is 2 Echo Zero Luna, 2 Echo Zero Lima Uniform November, calling the Earth. Is there anybody listening? It would be one awesome moon bounce transmission.
So if let's say you're cruising around on your moon rover in one of the craters, and you go really fast, you go up the rim and you launch yourself up off the surface. Would you call that getting some air?
I don't know. The moon's only got a very thin exosphere, so
I know. But what else would you turn?
It would probably be It would be like on those
getting some
bouncy toys we used to have as kids.
Getting some altitude, not air.
Space hop. Altitude, yes.
Yes.
Altitude, yes. Air, no.
Exactly. A little bit of a ring around a dwarf planet.
Yes, I know. Humana
Okay, now I've not looked up the pronunciation of this one. It looks like it's spelled Haumea, but how do you pronounce it?
Humana, Haumea.
Humana. Haumea. Well, potato. It actually is kind of potato shaped. That's pretty good.
Okay, I'm going to put a link in there. I know if you're on my Facebook, you've probably seen this comic, but I just cannot resist sharing. The comic is called Microcosm. It is a humorous look at the solar system. Look at it, laugh, giggle, chuckle. But come on, she's the only dwarf planet to have one. Seriously, who does she think she is?
So it's a dwarf planet beyond the orbit of Pluto and beyond the orbit of Neptune, obviously. Well, here nor there because they're so elliptical. The dwarf planet is on its largest axis about 2,300 kilometers in diameter. So what would that put it? About 1,600 miles, something like that. Rather flattened out, very elliptoidal. And it has a ring around it. I think discovered by a what's going for occultation, if I'm not mistaken.
Probably through occultation, yes.
Probably through occultation. That means when the planet went in front of a star, and they were monitoring the light from it, the light would have dipped off a little bit before the planet went in front of the star. Then it would have dipped off when the planet went in front of the star, and then afterwards dipped off just a little bit again. So like 3 light dips, and that would indicate, especially with the how deep the light went out. Obviously, it would be totally out when it went behind the planet, but slightly out, basically, or just dimming when it went behind the rings. Let's see. This thing's, I never really did that much checking on it. The thing orbits, it spins it just under 4 hours to rotate on its axis.
Mm-hmm.
It's very, very elliptical looking object, like they say, a rugby ball.
Mm-hmm. Yeah.
Or like somebody sitting on a soccer ball, football. Soccer. Depends on what country you're playing the game in, I guess.
Well, if you've got an oval ball, you must be. I hope you're playing rugby union.
Mm-hmm.
No pads, no helmets,
no teeth.
Most of them have still got teeth.
Okay.
The old cauliflower ear.
They keep them in a jar on the counter.
But no, I think a lot of the rugby union players actually use the boxers' gum guards. If the link to the comic isn't working, I've put up a better link to the Humana sketch. Hadria, I love it. I love Microcosm. I think it's brilliant, and I always post it on my Facebook when I get the next one.
All right. I gotta look up the pronunciation of this one. Haumea? Maybe.
Could be.
284-year orbit. And right now it's 50 times farther from the sun than the Earth. That's a ways out there.
I like the fact this cartoon's got Pluto and Eris in it.
Yeah. Yes. That's all right. Where's the list of dwarf planets? Is Pluto, Eris, Makemake, and this one, Haumea.
Makemake.
Makemake. Yeah. Either way.
But
Comet Assassin still out there.
Yes, very interesting comet. It's driving me insane.
Trying to image it.
Yeah, I'm trying to image it. I get lots of nice star patterns, star streaky patterns. I get the odd NGC object, and I don't get anything.
You mentioned stuff in the sky and one of them, Cassiopeia. It's kind of in the Cassiopeia region right now, actually.
Cassiopeia, yeah.
Yeah.
I'm told it's a very one of my colleagues from Comet Watch, Neil Norman, did recently go for it with binoculars. He's using 20 by 80 binoculars.
Okay.
And he said he found it was very diffuse and very hard to find with binoculars.
That must be in very averted vision. bordering on averted imagination.
Well, I've seen some very good images of the comet, and I've snagged a few previously. Let me just quickly just check something, because I hate to get my figures wrong.
Looks like it kind of flew a few degrees away from Capella a few days ago. It's slipping up into Cassiopeia now.
Okay, Assassin 2701, magnitude 8.5. It's steady. It's observable 80 degrees north to 40 degrees south, but it's visible best in the mornings. And the last visual observation was in October 2017. And of course, 3 days ago, a new comet was reported. 2017 T1 Hines was reported. Don't you just love it when I can go straight to the British Astronomical Association and get it?
Exactly.
But
it's like right now Cassiopeia is fairly high in the sky right now too, so that's a good thing. Higher in altitude than Polaris.
Mm-hmm.
So it's actually a pretty good observation. This would be a good weekend to look for this comet with the moon gone.
Well, actually, there's quite a few decent comets out there. Now, obviously, we've covered a lot of this on Wednesday night on Comet Watch. Myself and Mary, because Neil was off with laryngitis. Then we had some old friends from the Catalina Sky Survey and Space Watch. Rich Kowalski, Rick Hill, and Jim Scotty come on the show. And yes, the punning was very, very good fun towards the end of it. Things like if you keep looking at points in the sky, you'll get very fuzzy.
What did you have a magnitude on the comet?
Okay, let me see what I can find out. Yeah, no magnitude reported yet, but I'm just going to do a quick Google search. And of course, also a couple of days ago, it was the birthday of Shendaka, the chap who worked out the sizes of stars and what was okay and what wasn't. Okay, let me see. I'm on the MPC.
Minor Planet Center.
Yep. On the electronic circular.
Okay.
I'm just trying to see if they actually... 18.2.
No problem. Not seeing it.
Skyhound won't have it yet because...
No, it's a little faint, yeah.
Fresh off the press, it's just been confirmed by the Minor Planet Center. And in the immortal words of Marsden, if it moves and explodes, I want to know about it. That's what I think that's probably going to go up in my observatory on a plaque. I think he's greatly missed by the comet, the near-Earth object community, and of course the meteor guys, because he has such a wonderful sense of humor. And of course, before we had really good desktop computers, he could sit down and work out orbits by hand. He would sit there with a calculator and he would work out all the new orbits. I can think of a telescope that might get me down to Mag 18.
Which one?
It's a half meter I'm thinking about.
Think that's big enough?
I think it's big enough.
20 inches, I don't know. Yeah. Well, maybe with enough.
I'm thinking lots. It's going to take at least 8 or 9 sessions at night. Maybe 5 sessions a night over a 2-week period.
How much total integration time do you think?
For the image, the imaging maximum DL, I think we're talking leaving the computer alone to stack and process for at least a day.
How much total exposure time?
Given I would be working on 10 minutes a session, so every image, every fit file would be the result of 10 minutes imaging.
Okay.
So we're talking...
And how many of those images?
I get 3 fit files per imaging run, 5 runs a night, unless you get a couple of other guys to chip in with you and literally hammer the object.
Mm-hmm.
So a good 30 or 40 just to maybe see it initially, and it's going to be, even then it's still going to be faint. But you know what, that would be one heck of a thing. And the thing is, you would need I reckon you would need an octa-core. Maybe Rob, our wizard at production, would disagree with me, but I think that's octa-core territory. because the way things are going, the fainter you go, the more images you've got, the more CPU cycles you're talking, and the more cores you're talking. I think if you put it onto a single core CPU, you'd kill it. You'd lock up. Certainly with a multi-core or a quad-core, you're talking at least maybe 6 or 8, maybe 10 cores to get it done as quick as possible. But the fastest possible integration, you're looking at, I would say, at least 8 cores at 2.4 gigs. And at least a 4 gigabyte hard drive. Because you're going to have an awful lot of files, and you're going to have a very big file at the end of it.
No big deal.
Nothing for us, is it, Marty? We've all got big hard drives.
It's all empty space to fill, right?
Absolutely.
There you go, filling empty space.
Oh, dear.
Here's a cool one. Mars.
Yeah.
By NASA. Walk around on Mars, sort of. We put it in our chat room here. This one's pretty cool. It's kind of like it was a NASA virtual reality program, but they've kind of converted it for home computers. What's it called? It's through Google.
Yeah.
Another Google,
I've seen this.
Google
seen
project.
This
Yeah, it's let's see. Access Mars.
Yes, I've seen this.
So they've taken the images of Curiosity, like 200,000 images, and put them all together so that you can actually kind of go to, on your computer, go to Mars and look around.
Yeah.
Through the path that it took.
Bill Shatner did a recent show, The Truth is in the Stars. Nothing to do with astrology. But he was looking at science and the impact of science fiction. Yeah, well, okay, the impact of Star Trek on the current generation of scientists and space travelers. Quite a few well-known faces. Stephen Hawking, Colonel Hatfield was there. But the thing was, they were at JPL and they got to play with this. And so you had Bill Shatner and Colonel Hatfield both on Mars together, accessing this database. It was awesome because you could actually, what we could see from our angle was where Bill and I can't remember the guy's first name. Sorry, it's blown a blank. But it showed you where they were looking and what they were seeing. This is awesome. And I know a lot of people are getting really gushy about it. It on-site has made studying Martian geology
a lot easier.
Yeah, a lot easier. Quite right. It's almost as intuitive as it is going into the field here on the planet Earth, going to say Iceland or to Hecla, to actually get hands on the rocks and to see this, or a desert. Yeah. But the thing is, the really great thing about it is, if you can now do this on your own computer. Mm-hmm. And if anything, this is the reason you should be making your elected representatives' life miserable about putting money into science. I would not want to put this on my mobile phone because I think I need to take all my apps off, all my astronomy, my radio apps and stuff would have to come off, including my Netflix, and that is not going to happen. Mm-hmm. So, but yeah, if I had to have a second drive just to run this baby, I would in a heartbeat. Go on, try it, play with it, enjoy it. And this is why science is so important, because it allows geologists who are earthbound to actually get
an idea of what the Martian surface is like.
Thank you, Starstorm. This goes to show actually how live this show is, folks. Starstorm is sitting right beside me. She's tempting me with more corn candy in a moment because I can't eat it whilst I'm talking. But
let me give everybody a verbal. You can pick up all the links for our shows on our webpage, or on our homepage, by the way, or on our Facebook page. I'll just give it to you verbal in case you're listening. Just type in Access Mars, ACCESS Mars .withgoogle.com, or check out our Facebook page and all that. Is it time? It's almost
getting
time.
Close time, yes.
All right.
This is the away team to the USS Miranda, Captain Savick. The away team is ready to come home. We've had a grand time exploring Mars and a few other places.
That's right. We're standing on Mars right now, so beam us up. Everybody, appreciate you being in our chat room tonight. Appreciate you listening in. Don't forget, we'll repeat this program every 4 hours for the next 24 hours. And check out our Facebook page. Thanks, everybody.
Energize.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing.